Welcome to tonight's presentation on healthy buildings. I'm Tom Kirshner. I'm a board member of MAREA. MAREA is the Mid-Atlantic Renewable Energy Association. We are a all-volunteer nonprofit. We're dedicated to educational programs like tonight's presentation. We welcome suggestions for future presentations. If you have any suggestions, you can email us at themarea@gmail.com. Coming up May 27th, we have Colton Brown from the Pennsylvania Department of Transportation. Colton was with us a couple years ago. He'll be giving us an update on the EV charging build-out of the infrastructure in Pennsylvania. If you own an EV or you're interested in owning an EV or you're just interested in the conversion to electric vehicles, I think you'll find this a very interesting presentation. There's been a lot of progress over building out EV chargers, and there's a lot of work in the plans. So that'll be May 27th. All right, for tonight's speaker, Mike or Phil, are you going to introduce?
I'll go ahead and introduce Nathan. I'm pleased to introduce tonight's speaker, Nathan Stodola. I hope I'm pronouncing that correctly. Nathan leads the standard development team and serves as chief engineer at the International Well Building Institute, or IWBI. In this role, he maintains, enhances, and expands the strategies in the well building standard to promote health and well-being, with particular focus on air quality, thermal comfort, and sound. Prior to working at IWBI, Nathan worked at the University Transportation Research Council at City College, where he helped the New York Metropolitan Transportation Council create regional transportation plans. Nathan holds Master of Science degrees in Mechanical Engineering from Columbia University and Transportation Engineering from City College. In his spare time, he enjoys playing accordion and finding new bike routes in the greater New York area. Welcome, Nathan.
Thank you. And thanks everyone for attending tonight. I'm going to pull up my slide deck and get things started on here. Excuse me. Yep, so tonight I'll be talking about energy usage and the well building standard and how they interact with each other. So just some background about the well building standard and who IWBI is and what we do. So WELL is a leadership standard for buildings and organizations to create healthier spaces for people. It encompasses 10 concepts that you can see here, plus an opportunity for innovation that's there. You can think of it as a little bit like the LEED program for environmental certification of buildings, a little bit like the GRESB program for reporting on organizations, a little bit like the JUST program for the way that organizations themselves operate. It includes topics on everything from ventilation design to sick leave across these 10 concepts for organization, everything that's aimed at improving the health and well-being of the occupant. There are over 500 strategies in the program, and all backed by over 7,000 citations and sources as a basis for including them. So it includes things like use of indoor plants within mind towards designing for biophilia, and having access to daylight for being outside, or promoting use of cycling as a way to for transportation, enhanced acoustic comfort. And we have been around for a little over 10 years now. It doesn't go quite all this way back on the graph because the numbers in the beginning wouldn't show up, but as you can see here, that it's now in use on over 5 billion square feet across the world, in over 100 countries, and a large number of the Fortune 500s are also involved. This happens either when they come work through our program as through a certification or through some of our other offerings. So what Well started with, and what you will be most familiar to you if you're familiar with the LEED program, is the certification. There's a certain number of preconditions that must be met and some number of optimizations to get some number of points towards a different level of achievement that's here. And that represents the real leadership for particular locations and working with things. But we also have what we've identified as these ratings, which are themed subsets of the features. And this is a less intensive way to get involved. Some people see it as a stepping stone towards the certification. Some see it as a way that in and of itself. And we began with the health safety rating, which was a collection of operational strategies to address acute health needs at the start of the COVID pandemic, when we were hearing from our clients saying, yes, physical activity and access to stairs is great, or indoor plants for biophilia is great, but right now I'm worried about keeping people alive. And so we worked on identifying the strategies within Well that would be suited to that purpose and made the health safety rating. Since then, we've created several others as well. And then this can lead up to what we call the Well at Scale program, which is an opportunity to streamline documentation for review from clients as they work with the program over hundreds of locations, but also to reward incremental achievements. That if we have one building and they have done strategy, nice, congratulations, but it's not really something that we need to get involved with as the certification program. But if you're a company and you have 500 locations and you've done that strategy everywhere, it actually affects a large number of people and has a big impact, and that can be portrayed in an organization's Well score that's shown here. So looking at everything from strategies across a whole organization, towards leadership to a particular building, towards themed awards at a building, there's ways to adhere to the strategies within the Well program at any level. I'm going to get started on the main focus of tonight and why I think you've asked me to be involved. And this is how Well works with, it interacts with energy usage. So while our program is not meant to be anything about saving energy or using more energy, hopefully, there certainly are some ancillary effects on energy usage from the strategies that are there. Everything that's in Well is in Well because of the health impact, but sometimes there's also an energy impact. And this study here that was written in part by one of our thermal comfort advisors, Jianan Lau, did an assessment on all of the strategies that are there and found that some of them take more energy, some of them take less energy. And depending which ones you picked and what your climate is, that could mean that you might use more energy, or it could mean that you might use less energy that's there, because some of the strategies, like increasing light levels during the day that for the purpose of the visual effects, for the purpose of circadian effects, the light at the eye as opposed to on the work surface, that's sort of a change in what people design for. That might take more energy, but there's a lot of strategies there that actually can help reduce energy. So I mentioned there are 10 concepts within the program, and we'll start with the very first one here, air. Just briefly, I'll go over everything that you'll see in it because if you're not familiar with it. So the fundamental aspect of Well, the reason that it's our very first feature in the whole standard is on-site performance testing. That this doesn't just involve a documentation review of some drawing or some policy that's there. It also includes actual on-site tests to make sure that buildings are performing as they're intended to. So air quality test involves tests for particulate matter, VOCs, inorganic gases that are there. And then there's a counterpart, enhanced air quality, which you can see this was a precondition. This is a must-have for every certified building, and you can get a number of points if you have even better air quality that's there. There's strategies that involve not only design, but also policies like smoke-free environment. So looking at the design, the ventilation that's there, meeting the requirements for ASHRAE 62.1, also enhanced ventilation, exceeding those ventilation rates. Promoting operable windows to have people have the ability to bring in more outdoor air when needed, having sensors and displaying that information of the air quality to the occupants of the building, permanently installed sensors, managing pollution infiltration either through the front door or your building envelope, minimizing combustion through electrification or low combustion like furnaces and the like. Source separation, keeping your bathrooms and your kitchens away and your copy rooms away from other areas where the occupants are. And then here's a suite of air treatment, looking at particle filtration of outdoor air, treatment of recirculated air, and then managing mold and microbes on the cooling coils. So now we've got a summary of what we might find in air. Let's take a look at the ones that will have, which ones might help save energy. So first, in our enhanced ventilation design, I mentioned that this includes one pathway towards earning this is simply to increase your ventilation rates, go 30% above what ASHRAE 62.1 says. And that's a way that is guaranteed to lower the CO2 levels that are in the space. But it definitely will take more energy, especially if it's used indiscriminately when spaces are unoccupied. So another pathway that we have is that using demand-controlled ventilation, measuring the CO2 levels. Now, I know there are also methods that directly measure occupancy or measure other things, but CO2 is one of the most common ones that's there, and saying provide however much air it takes to bring this CO2 to 500 ppm above outdoor levels or 350 ppm above outdoor levels. And this is finding that, yeah, and this can keep the energy usage down when the space isn't in use, which can save energy. Here it says from this Department of Energy study, around between 6 and 18% savings that you could expect from using this compared to just a static ventilation design that takes no account of the people in the space. Another strategy within this feature looks at displacement ventilation, the idea of providing air at a low level and at a slightly higher temperature so that it slowly will rise up to the top, and that will enhance mixing. And when, like for instance, in ASHRAE 62.1, there are certain ventilation rates that are prescribed, but then it has a Z, which I think is the zone effectiveness, is what that means. But that's a factor that says multiply whatever you're supplying by this number. And with properly designed ventilation systems, that number can be higher than 1, which just means that you don't actually even need to provide the flow rate of air that is specified. You can get away with less than that because of that factor that's there. And as a result of that, displacement ventilation systems can reduce energy demand by, and here they found reasons was not only could they get away with lower airflow, but that also was just more effective at managing thermal comfort within the space, which is one of the main reasons for the HVAC system. But they were able to get away with heating and less cooling for the air that was being supplied when done with demand control. And moving away from ventilation ones into the air treatment systems. So obviously, anytime you put a obstruction in your duct, like a filter, that is going to take energy. Fans are going to have to work harder to blow the air past whatever it is that you put in there. So compared to having no filter at all, time you put a filter in, you're going to use more energy. But there's more and more groups are saying, yes, you should put in a filter. It's important because outdoor air can be bad. And if especially in countries in the Middle East and in much of India and in China. Outdoor air can be really bad. And in some parts of the US, it can be not great, though on a global scale, even the worst part of the United States on an annual average is not that bad. So looking at that, looking at the outdoor air levels, that's an important part of designing your system. That there's some recommendations that just pick some blanket number and say, always put an MERV 13 filter on your return air. Always put in a MERV 16 filter, like a HEPA, or not your return, on your supply air for managing outdoor air. And of course, more filters is going to mean cleaner air, but it's going to be a lot of energy. And how clean do you really need it to be? So, example, if your outdoor air levels, your annual average is 80 or 90 micrograms per cubic meter, like in the Middle East, or even 30, like it is in Poland, then a high level of outdoor air or a high level of filter is probably warranted. Yes, it's going to take some energy, but like that's going to have a real impact on the people. Whereas in other places where it's not quite so bad, you are going to be using a lot of energy to filter that, and it's going to be bringing it down to a level that may not be necessary. So by looking at the outdoor air and by picking the filter that's appropriate for that, that can help you minimize, I guess, rather than save energy, it'll help you minimize the energy penalty that you're paying for that. Other treatment systems actually can save you energy that's there. So this feature is all about looking at cooling coils, because with cooling coils within your system, I mean, by definition, in almost all parts of the world, they're going to be bringing the fins themselves are going to be lower temperature than the dew point of the air that's going over. So by definition, that's going to create condensate that will then collect in a pan and drain out somewhere. So you're going to have moisture on them. And like mold and microbes grow if they have food and if they have water. In food, they eat just about anything. And they eat just even tiny specks of anything that might be flying through the air that you never even notice that's there. So that means the limiting factor is water. Water would be the thing that you could control. But as you just discussed, cooling coils, definition, are going to be wet. So you're kind of in a bind there. That you've got a wet space and you're going to have food, so that's going to be a space that mold likes to grow, and can go and do regular cleaning, and that's one common path, and that it works. It's effective. Every so often, go and inspect it, see if anything looks bad, spray some stuff on it if you want, wipe it down, get rid of anything that's on there, clean it off. That will help work with that. But I'm thinking through the exact terms in the hierarchy of control. That's a procedural control that has opportunity for failure. If people forget to do it, if there's a change in management and they don't look into and they forget to write it down, then people stop checking in it, and then the system is working. And also, it's a fairly labor-intensive checking that. So it's where this idea of the ultraviolet irradiation on the cooling coils comes in. Yes, there's some electricity usage for running the UV lamps themselves, but it's not a lot because cooling coil isn't going anywhere. The other way that you can use these UV systems is trying to irradiate passing air for microbes, but there it just flies by. So you need a lot of energy to make that one work. But for UV and cooling coils, yeah, that cooling coil isn't going anywhere. So you can just continually blast it with a small amount, a small power output, and that will be very effective and shows that this going to, one, of course, be healthier, because it's never good news if you are blowing air over cooling coils and then sending that air to people. Like, that's just bad news for everyone, and that's why it's in well. But also, it's good for energy, because when all that mold starts growing on the cooling coils, and that impedes the airflow more, that increases the pressure drop, and it also means that the transfer goes down, because now you have these mold growth in the way between the coils, which are supposed to be cold, and the air that it's supposed to be transferring heat to. So your pressure drop goes up, your cooling coefficient goes down, and so it uses a lot more energy. So the little amount of electricity that it uses to run the lamps is more than made up for by the savings in cooling load and pressure drop load that's experienced there. So this is definitely something that can be net save in energy. We'll look at some of the other concepts within it. So looking at light. Light has features aiming at daylight. So a preconditioned light exposure, a minimum level of daylight, and then having various architectural design strategies, or the daylight simulation, which is technically time consuming to figure it out, but it's more agnostic to the design conditions. It provides more flexibility to teams. So there's both of these can be rewarded. Visual lighting design, designing to make sure that people can see the tasks they're doing. The circadian lighting, the design that the light that reaches people's eyes, that's circadian active, that can help them keep in sync their sleep-wake cycle. And then looking at electric light quality, the glare, color rendering, and flicker in here. And then looking at occupant lighting control in the space. That is our summary of everything that we have in there. And looking in particular at these, we're going to focus on daylight, which is the most obvious one, how this can help save energy. So one of the requirements, as example, in the daylight design strategies, we say 70% of workstations are within 25 feet of the envelope glazing. Or for more points, that 70% are even closer to the envelope glazing. And now, and this takes some intentional design from the teams. You can just have lots of windows and then just provide the same amount of electric light as before, and then you're not going to save any energy at all. But hopefully you're doing that in a way that affects the way you operate your lights. And so for the study, for example, says when you do that, whether it's with sensors to look at the amount of daylight that's coming in, or just like intelligent use of switching, that you have maybe different banks of lights and you can turn off the ones that are closest to the windows during the day. You can save between like a third and 3/4 of the energy from electric light that you have. And we can give a nod to this when we go back to our circadian lighting design, both LO2 and LO3. These features are others that are performance tested. There's an on-site test that's there, but we have them tested at night to take out any consideration of daylight that's there. And the reason is the variability. Because these tests take place on a particular day, or sometimes 2 days, if the building is very large, then we initially did our tests and had a higher target, but we did our tests that included daylight contributions during the day. But then every time a project team would fail, they would tell us, oh, but this was the cloudiest day that we've had all month. It's usually so much sunnier than this, so we should be getting some credit for this. To avoid that happening over and over again, we decided, well, let's go and lower our target a bit, assuming that there's going to be daylight throughout the space, and do the tests at night. That way, we know we are getting a consistent amount. And in terms of picking the target, we also say, if you show us you have great daylight by meeting one of these daylight optimizations, like the one I just showed, we'll decrease your target here. So instead of doing 150 equivalent melanopic lux, which is the circadian metric, if you have good daylight, it's only 120 that you have to meet. So that's the way that we acknowledge the daylight contributions and say that you don't have to use as much energy for this if you have good daylight within your space. Next, we'll look at thermal comfort. So just again, a brief summary of the whole feature here. We have our thermal performance. So this is an on-site test looking at measurements that will contribute to the metric PMV, the predicted mean vote. So that includes the dry bulb temperature, mean radiant temperature, humidity, and assumptions about airspeed, occupant clothing, and occupant activity level. And from that, we find out if the space is meeting the criteria, the PMV plus or minus 0.5 that's described in ASHRAE 55 that's there. So that's our performance feature. TO2, verified thermal comfort, is a survey. And that can actually be a pathway to meet TO1. The idea, we have a feature in the community concept that says, do a survey and gather this information, and hopefully you'll do something useful with it. But it doesn't really matter what people end up saying or if they don't respond at all. But for this feature, we say they have to, you have to ask them about their thermal comfort. A certain quantity of them have to respond, and enough of them have to say that they're satisfied with the space. I like to say that the point of this feature is not to issue a survey. The point of this feature is to test whether this space is providing thermal comfort, and the survey is the instrument by which you do that. And one of the reasons we have it here is that ultimately thermal comfort is a personal feeling. People are very bad at detecting air quality generally, and for a lot of water quality, they're very bad at it. That the amount of particulate matter or ozone or in the air or lead in the water that constitutes a health hazard is far lower than the amount that we'd ever be able to detect. So you'd never want to go and say, hey, what's your preference, or what's of your water quality comfort or your air comfort? And in fact, often when if you make a space hot or a little bit warm and you ask people about the air quality, they'll say the air quality is bad, even though they're just reacting to the comfort. So this doesn't work throughout a lot of the space, but for thermal comfort, it does. That's ultimately what matters. So that's why we have it here. Then we have features on thermal zoning so that you can have different spaces, different temperatures, or at least providing different amounts of heating in there to maintain the same temperature if you need to. Individual thermal control. This includes things like fans or heated foot warmers, radiant thermal comfort, monitoring your comfort there, using the humidity in the space separate from just the PMV, also keeping the humidity between 30 and 60%. Enhanced operable windows. So more than just having operable windows for managing air quality, it's also doing it in a way that will either minimize any thermal discomfort in the winter or potentially enhance thermal comfort in the warmer climates. And then looking at outdoor thermal comfort. So the first one I want to point out here is having an energy effect is not an engineering feature at all. It is in our individual thermal control. It's the dress code. So have a policy in place that lets people choose their level of clothing that's there. When you look at the parameters that go into PMV, one of those is the clothing insulation that's there. And if everyone is wearing a suit or everyone is wearing Bermuda shorts, that can have a big impact on whether this exact same space is considered comfortable or not. And also because people have the different preferences that's there, it's a big way that you can allow for that individual control within the space, even when everyone is ultimately experiencing the same environment. And this itself can have an energy impact. So yeah, this study is finding that when you let people have flexible clothing, that you can have a lower heating set point, and that's there. So, and just similarly, a higher cooling set point, so that you don't have to spend as much energy conditioning the space to exactly some temperature for a particular clothing level if you let people change what they're wearing. The other one I want to talk about is that outdoor thermal comfort. And this has a number of features, another number of strategies, the first one of which is managing outdoor heat by having shaded spaces, whether it's your plazas or your parking areas or your pathways that are there, to prevent like these giant asphalt fields that just bake in the sun that's there, or they're having people walk through or stand outside areas that are totally unshaded. And the idea with well is that one of the reasons we wanted is the people themselves can experience the shade as they are walking about. And so that can help with their own thermal sensations while they're outside. But by providing those coverings, especially if they're done with trees, or if they're done with other things that might not absorb the sunlight in the same way, like solar panels, which would convert some amount of those to that heat into energy into electricity instead. All that shading can also have a beneficial effect on the whole. And here, like the CPA website describes how vegetation that shades buildings and shades other surfaces can reduce the energy demand by 10%. And this is probably something that's a single building doing it isn't going to entirely change everything. But when you're looking at a city or a block, if every building is working like this, then that can have a major effect on the microclimate that's there and have an impact on energy that's needed throughout the space for each of those buildings there. Then finally, I do want to talk about in our innovation that we have one feature here where we sort of acknowledge that yes, well is about health of the occupants within the space that's there, within the organization. But ultimately, if we don't address carbon emissions and global warming, we're all going to die a fiery death. So that we have, like, planetary health is human health. We don't want to go and recreate every strategy from green building rating systems and say, oh, and also save energy, use low flow fixtures because that saves water and that's going to be less energy for the infrastructure and that will help. Also, have high thermal insulation on all your buildings so that it's less heat loss and that'll save energy. We don't want to take step by step and just recreate a green building standard within our program here, but we want to acknowledge that addressing carbon is a human health issue. So the last feature that we have in the program is saying, for your entire organization, assess your carbon emissions. And like for 1 point, start with just scope 1 and 2, which is what do you burn and what does the utilities burn to get you your energy and your water that's there. And that's the easiest thing to figure out, and it's often a good start. And then we say, but then look at scope 3, which is what are the emissions that result from everything else that you do, whether that's employee commuting, whether that's the embodied carbon in the buildings, whether it is the downstream emissions from the products that I produce. So obviously that's a much bigger lift to be able to do, but it's also important. So we reward each of those. And then we tell people to set carbon goals publicly. So say, hey, set a goal, either one that's at least a 3% reduction per year or one that's been approved by the Science Based Targets Initiative, and then your carbon goal. So show us that you set a carbon goal in the past and now that you actually have met those, because someone's saying, oh, by 2030, I'm going to reduce my carbon emissions by 15%. Commitments like that, those are a dime a dozen. But here, this is someone saying, yes, here was me committing to do something and here's me showing that I've actually done it. And then once you've done all that, then there's rewarding them for actually getting to carbon neutrality. So obviously, this feature has an impact on energy. Like, again, we aren't specific. We aren't saying you should use economizers in your ventilation and heating and cooling system, or you should have solar panels, or you should put in electric vehicle chargers. Like, we don't take out specific strategies they need to do, but it's up to them to pick whatever suite of strategies they feel is good for them, so that they can help meet the carbon goals that they've set here. Here I've been talking about well and energy and all of those, but I do want to get back to the point that, like, the well building standard is not designed to be about energy. There are ancillary energy benefits for many of the features, but ultimately it is about the human experience. And so what I want to leave people with is just the idea that, like, well is investing for health. And investing for health pays back. That when you go and implement these strategies and put resources towards your people in the space, then you'll come out ahead. That people are the most valuable assets in your building. You might spend $1 to $3 a square foot on energy, $10 to $30 a square foot on your rent, and $100 to $300 a square foot on the salaries and benefits of the people that actually work in the building itself. So that, yes, the saving energy is important. And as I said, if we don't figure out our carbon emissions, we're all going to die a fiery death. But the reason that to do well is for the occupants of in the space. And here, like, in addition to every strategy within well being based on one of those 7,000 citations I mentioned, saying, yes, here's the evidence on why this particular thing is a good idea, there's a growing number of studies out there that have actually looked at well certification compared to non-certified spaces. So here is just one to highlight. You can see more about it in the website at the bottom there, but it was involving over 1,000 pre and post occupancy surveys. So, like, before they were in a space, after they were in a space, and found that it was almost a 30% increase in percentage points for the satisfaction within the workspace, 10% increase in reported mental health. It was like a 2% increase in reported physical health, and then, as you can see here on the right, generally. I like to compared with the pre and the post, you'll see much more green in the post than beforehand, which means that these well buildings do have a benefit. And I will also note that, as to the surprise of no one who's been involved with post occupancy surveys, thermal comfort and acoustics are far and away the largest points of complaints. That if you go into any space virtually and say, hey, what are the things that bother you most about this space? You can put money on it that it's going to be thermal comfort or acoustics, and you're going to come out ahead. So, I've been involved a lot in our acoustic strategies, and we get comments saying, "Oh, we need more acoustic strategies because there aren't enough strategies that we have in there." And I say, we have strategies that aim at looking at distracting background noise, at privacy and noise isolation, at intelligibility within the space, and addressing hearing loss. If you're not doing one of those things, you aren't addressing acoustics, and most people don't address acoustics. They try to address thermal comfort, and they get it wrong, and they don't even think about acoustics. But hopefully will inspire more people to be looking at those, plus all of the rest of the programs there, but to improve the performance of their most valuable asset, their people, and then also, if they choose the right features, and to improve the energy efficiency of the space. And with that, I think we've got plenty of time for some questions here. I saw a number coming in through the chat, but I'm happy to be going through some of these questions that I've brought up.
Great. Chuck, can you do the questions? Thank you very much, Nathan.
Okay, I need information for insulation for a home built in 1970. Can you give me a resource, a link for insulating an older home? Are you there?
The, well, yeah, I'll tie that into the next question that I see. But one of the things that I mentioned is that the main purposes of WELL is not looking at energy, that a lot of the features that have an ancillary benefit that's there's ones that are looking primarily at human comfort. And I do understand that if you have a place that is very drafty or very cold, that is going to be uncomfortable. That's there, but I don't. Yeah, I don't have anything offhand about looking at retrofit insulation. I'm sorry.
Okay. The next question is, are there standards, the WELL standards typically applied mainly to new construction, or is there significant opportunity for retrofitting of existing buildings?
I would say in general, there's actually a ton of opportunity for existing buildings. When we first launched WELL 10 years ago, we called it new and existing buildings and new and existing interiors, but fully 40% of our standard were preconditions. It's things that you had to do if you wanted to get certified. And some of them were incredibly specific, like saying you had to have revolving doors or vestibules on your entrance. And that we're running into a lot of buildings saying, an existing building, I cannot go and suddenly build a vestibule that's there. And we thought about it and we were like, yeah, well, really, that's not the most important thing. If these buildings are doing so many other things, we don't really care if they've done the vestibule or the revolving door. So when we've launched WELL V2 pilot in our current version, WELL V2, we looked at, I'm sorry, my camera seems to have disappeared. We looked at all of the strategies again and tried to determine which ones were absolutely mandatory, which ones would we not feel comfortable if a project didn't do that, and greatly reduced the number of preconditions within that were required, and increase the number of optimizations, the flexible pathway. And in doing so, it opened up the project to existing buildings, because they all said, okay, yes, I can figure out a way that I can meet the air quality standards. I can figure out a way that I can meet the basic lighting requirements and the basic materials requirements. But then they could focus on some other optimizations if they couldn't do some of a certain strategy that's there. And I think that I would say the other reason that we have so many existing buildings is now through our ratings. Like the health safety rating is specifically designed for facilities operation and management. It's meant to avoid capital intensive designs entirely. So it was very popular with our existing buildings. And then also like the WELL at Scale program, where we reward incremental progress. Like when you enroll every location that your company operates, we'll get on the board just by having some of these like HR policies. If you can show us that there's this flexible dress code policy that applies to every building, it's 1 point on the board for your whole organization. So it's a real way that they can get incremental improvement. And then when they have the budget to focus on a particular building and undergo some renovation for certification, they can do that.
Nothing exceeds like success, right?
Right.
Okay, the next question is, with the daylighting and increased window, this question is about, are you doing anything with those windows to protect birds from lethal window strikes?
We don't have anything in the WELL standard on that. And I think this is one of the examples of being differentiated from green buildings. It's not that we don't think that these are important aspects, but they don't have the direct relation to the health of the building occupants that's there. So I often say that like there's the Save the Tigers features and the Save Water features. Like those are all great, and people should be doing them, but they belong in the green building standards and not as part of WELL.
Okay. Good answer. Wondering about roof gardens and vegetation. Would they influence the thermal envelope for the building?
Yeah, absolutely. So the roof gardens can be a huge help with the heat island effect that's there. And that can help reduce the cooling load a lot. So that can help teams earn our outdoor thermal comfort feature. It will also, we also have several features about access to nature, for example. And if you I know that sometimes these rooftop gardens are meant to really only be for thermal purposes, and there isn't an expectation that people go up there. But other times there's a hybrid, something that's there for thermal reasons or for water retention, that's also being advertised as an amenity, whether that's just for the ability to interact with nature, and we have that in mind in our biophilic design strategies, or if that has food-bearing plants. And we have that within our nourishment concept, because there's studies that show that people who garden eat more vegetables. It's not that necessarily that just that the food that they grow there goes into their diet, but it's the act of gardening gets people to eat more fruits and vegetables that's there. So we reward that within our nourishment concept. So I think these rooftop gardens are a great synergy between thermal comfort, between mind and nourishment.
Great. More rooftop gardens. How can you tell us a little bit about WELL strategies applicable to residents that also reduce the energy consumption? Maybe the top 3?
Yeah. So we, for the longest time, only were tangentially involved with residential. We let in multifamily residential, and there was a fair number of them, but our bread and butter has always been commercial office. But a couple of years ago, we began work on the WELL for residential and creating a system that was designed to work primarily for residences, and so that's now available. It's in pilot, but we aim to be releasing it and integrating it into our other programs soon, and it's open for registration. But back to the original question, what are some of the strategies that that can be used? I think you'll find some of them are similar. Things like having design for the vegetation around it, so you're not there's not too much concrete and paved area within the space. Designing for one of them is looking. There's in water actually. It's an interesting one. So the IWBI, which is a plumbing organization, they've recently produced, they call it the water demand calculator. And that for the longest time, people that were just plumbing engineers and builders worried about having enough water. And so they'd basically go in and say, all right, what would happen if everyone comes out of their apartment and turns on and flushes the toilet at the same time? We need that much flow rate. And so there would be gigantic pipes that were there, which would mean that the water would move very slowly through it. And that would be especially bad looking at heated water, because then the water is going to cool off as it goes there. So it's going to take you longer to get hot water because the pipes are so big there. Whereas if you have pipes that are more logically sized, then there's not as much water that needs to flow before the hot water comes. And then thinking about a lot of the green design, like low flow fixtures and all of that, so that sort of just made it worse, because you had these giant pipes that were sort of worst case scenario to begin with, and then fixtures that were pulling even less water than usual. And that really started being one, more energy consumption to keep it warm, but also potential health concerns when you had all this warm water, which was a problem with Legionella. One of the things there is just making sure that you're only designing for the appropriate size of water or pipes for the flow rates.
Okay. The other question, are there similar, hold on a minute, I just lost this. Okay. How is access to nature addressed? Survey that you showed gives 30% improvements.
Can you still hear me? My computer just restarted, but I'm connected to my audio by phone. Can you still hear me?
Yes, we can hear you.
Excellent. So I'll just ignore my computer. Access to nature. So one was all done by a through survey. So there was over 1,300 occupants that were surveyed as part of that before and after. And a lot of them were just questions like, please describe your thermal comfort. Please describe your satisfaction with access to nature. And so that would involve, again, thinking about the rooftop garden, they might say, oh yes, I've got great access to nature. When I need a break in the middle of the day, I can go and up there to the roof and hang out with the butterflies and the flowers. So it's a subjective response to like their satisfaction with nature.
Okay. And are there similar initiatives for building residential building and neighborhoods?
Yes. So as I mentioned, with residential, we have our Well for Residential program, and I can put in a link once I get back in here or in the chat where you can learn about that, or it's all, you can find it on like in the website on wellcertified.com, and one of the menus that's there. And we also have a well community standard that's in pilot. That's about 8 years old, and we've been working with it very slowly to see where it goes. The biggest trouble that we've had with that is not the requirements, but the project owner and the management of the system. Like, there's tons of evidence and strategies about what is a good way to get people healthy in the design of a neighborhood or of a community that's there. But figuring out who is it that's going to sign up the community, who is it that's going to document it to us, and what is going to be the boundary, and how much do they control, and how much do other people control? That has been the challenge. It's something we're continuing to look at, but within the Well for Residential, as we're calling it, yeah, we are happy how quickly that is being picked up.
Okay. One of our attendees has given a plug for Westchester Insulation as a group that can retrofit and provide insulation for old homes. They just did their 1943 house, and the house is now snug and warm. So Westchester Insulation might be a place that the other participant that was asking about insulation might want to contact. I have, I'm not sure, I'm looking to see if there are more questions. Oh yes, do you find building projects pursuing well are also pursuing LEED?
Absolutely. So as I noted, like we really emphasize how well is designed for the health and well-being of the occupants in the space, and we encourage people to work with both programs because we think that planetary health is very important. It's just not part of our program that's here. So especially looking at new construction, because BD&C is the most popular of the LEED programs, that there's a ton of overlap. And almost since the very beginning, we created what we call crosswalks, which is looking at assessment that we did of these other rating systems. We have one with LEED, with BREEAM in the UK, with Green Star in Australia, all over the world. And hey, well, about 20% of the standard has some amount of overlap, and often it's like for different reasons. How to recognize that. So, for example, we look at, let's say, access to stairs within a space. LEED likes that and has it being important because using stairs over the elevator takes less energy, or using transit over driving cars uses less energy, whereas in WELL, those are there because they're more physical activity. But ultimately, it's the same requirement in both cases. So our crosswalks allow, when a project has been certified in one of these other programs, rather than also documenting that they meet the requirements in WELL, they can just show us their scorecard from LEED or BREEAM and say, look, I was awarded this sustainable sites feature, or this location and transportation feature, and you've declared that those are close enough, so I can get that WELL feature, those points, without having to document it separately. And that's been a big time saver for teams that are working with both programs. And actually, since many of our reviews are done by GBCI, the certification body behind LEED, we've even stood up a dual review process for projects that are simultaneously undergoing the pursuit of certification for LEED and WELL. And so in that case, they can have the review for both of them take place at the same time and go for both of the submissions at once.
Great. Great. So I have a question about a couple of successful examples of lowering carbon intensity at a large company through WELL.
Can you repeat that question?
Do you have a couple of examples of lowering the carbon intensity through improvements made through WELL recommendations? At a large company,
yeah,
where there are multiple buildings that have all been given WELL certification and are monitoring their carbon reductions.
That is something that I think I'll need to look into more to see what our projects and what documentation that they've been putting in. Because, yeah, I have that information off the top of my head, but I can look to see which of the projects have been pursuing our carbon and reduction feature, because as part of that, we would expect that those reports are published publicly. So we should, there were about
that would be a great opportunity for some publicity, some positive marketing. Because like you were saying, one of the main things is the ability for us to reduce our carbon intensity to lower our emissions. It's a thought. Okay, there's another comment here about insulation. For insulation services, utilities, PPL, PICO, they maintain lists of potential service providers on their website. Also, you can get multiple quotes and references and have them explain the materials and methods, to be sure to discuss how they use them and what the cleanup expectations are, so that the insulation is handled properly. So that's another comment from participants. Are there any other questions from the audience? Okay, Bill, I don't hear any other questions. Does anybody want to unmute themselves and ask a question? Hearing no comments, just crickets. Bill, I'll turn the stage back to you.
Okay. Well, thank you so much, Nathan, for sharing with us the WELL building projects and the standards that it's eye-opening to and encouraging that there's an organization out there pursuing this, because it's often gets kind of rolled over in the construction process. So it's great to see that happening. And we wish you the best in continuing to promote and expand the adoption of it. We're appreciate everyone joining us this evening, and we'll look forward to seeing you on, I believe it's May 27th, when we'll be hearing about EV and the EV charging stations across Pennsylvania and that project that continues to push on ahead. So we'll look forward to seeing you next month. In the meantime, feel free to email us with questions or refer to the website for any additional information. Thanks everyone for joining us. Have a good night.